Sorry?
Nothing.
You don't like the angle? You want me to adjust it?
No, it's okay.
Okay, good. Prove that these 3 points are collinear. It's been a while. How do I decide whether some points are collinear? What does collinear even mean?
They're all linear with each other.
Parallel.
Not parallel, collinear.
I was just guessing.
Yeah, don't guess.
In one line.
In one line.
Oh.
How can I prove with vector methods that these 3 points are in a straight line? Yes?
I'll show it.
Okay.
Wouldn't it be like the difference between A and B and the difference between B and C will be like scalar multiples of each other?
Good. Rather than difference between, we would say, I'm going to show that A, B, and you can either go AC or BC, yes, are scalar multiples of each other. So we're going to work it out. AB is, though, the difference, B minus A. Remember that notation? Little letter means the direction vector from the origin to that point. So B minus A is 1, 3. If you prefer, you could write I hat plus 3j hat, whatever you like. And BC is C minus B. 4 take 2 is 2. 14 take 8 is 6, which is 2 AB. So this one is a scalar multiple of this one. That means they must be in line. Warm your brains up. Let's try a slightly trickier one. Here's a triangle. Now, my suggestion for any time you draw diagrams for proofs is don't try to draw it so that it looks like what you're trying to draw. You'll see as we go through. In this case, and anytime you're drawing a triangle, unless you know it's isosceles, or you know it's equilateral, or you know it's got a right angle, don't draw it with right angles, don't draw with equal sides. Because you want to not let your brain assume something that isn't actually true. You want to force your brain to prove everything. So I'm going to go A, B, C. Which way are they going? Okay, A, B, C. And I'm going to get the midpoints of these two sides. Notice I'm deliberately trying to draw it so they don't look too close to parallel. That's actually what I'm going to try and get you to prove. D and E, so this is midpoint, and that's the midpoint. Do you remember these kinds of markings? Grade 7 maths was a long time ago. And you need to prove that DE is parallel to AC. Is parallel rather than collinear. In fact, I'm going to make it more. And DE, the length of DE is half the length of AC. Any ideas?
Dot product.
Why would you think dot product, Ben? Are you just calling out random vector things you know?
Yeah.
Not helpful. Problem solved. Think about it. Look at this. I'm going to prove a direction and a length. So actually, I could prove this in a single statement with vectors, right? That's the same as saying DE, the vector, is half AC, the vector. Okay, let's look at DE. To get from D to E, I could go via B. DB plus BE. Remember that from your vectors? To get from D to E, I'm going to go D to B and then B to E. But DB, D's the midpoint, so DB is half of AB, right?
Alright.
Half of AB. Similarly, BE is half of BC. Can you see where we're going? Half of AB plus BC, but this is AC. Make sense? That might be enough. It probably is. Let's have a go at the dot points in the syllabus. Prove that the diagonals of a parallelogram meet at right angles if and only if it's a rhombus. The diagonals of, Ryan knows this, I'll explain this for the year 11s. These are 4 specific dot points you have to be able to prove. So certainly at least one of your questions on your exam, when we get to the end of the year, is going to be one of these dot points. Word for word, exactly what that says.
Are we not getting tested on this term?
No. Well, this term, yes. End of this term.
Okay, I have next term.
Sorry. At the end of the year means the end of this term.
Oh, okay, right.
So, prove that. So, you're going to get a question that says just literally one of those things. You have to, how do I do this? Draw the diagram. Now try and prove it. The diagonals of a parallelogram. Come on, pen. Parallelogram. Meet at right angles. If and only if it is a rhombus. I suppose I should start by saying, do you know what a parallelogram is? Do you know what a rhombus is?
I don't know what a rhombus is.
You don't know what it is?
Like,
just
not
like a-
what's defined as
Well, what's a parallelogram?
parallel lines and
Parallel lines. Is that a parallelogram?
close.
No.
Well, it's pretty close. You just need 2 more.
Give me a good 2 more.
Yeah.
Is that a parallelogram?
Getting closer.
No. Can someone give me a definition of parallelogram? Someone other than you.
A 4-sided shape with both opposing sizes being parallel.
Beautiful.
That's
I
what I
like
said.
it. Right? I like it. So then what's a rhombus?
Same thing but tilted.
But what?
Like specifically tilted, isn't it?
No.
Oh no, is a rhombus this one?
No.
This one?
No.
What?
That's not parallel.
Nope.
No, a rhombus is parallel, isn't it?
A rhombus is a parallelogram where all 4 sides are the same length.
Okay, well that's kind of silly.
You should know that.
So a square is a rhombus.
A square is indeed a rhombus, and a rhombus is a parallelogram, correct. And a square is also a kite. And a kite is not a parallelogram. Oh no?
Yes, it
Yeah,
is.
no, a kite is not a parallelogram. You know what a kite is?
Do they not follow? Oh, never mind. Yeah, never mind.
So a kite has 2 adjacent sides equal.
Yeah.
A parallelogram has 2 opposite sides equal. And a rhombus and square have all 4 sides equal.
I imagined it like symmetrical. Like
Yeah, it doesn't have to be that. Okay. So I need to show that if it's a parallelogram and its diagonals meet at right angles, then it's a rhombus. I also need to show that if it's a rhombus, then its diagonals meet at right angles. If and only if. Have to go both ways. Remember that from your proofs? In this one I can get away with only a little bit of work. So, first step, draw a parallelogram. So, it is a parallelogram, but do not draw it so the sides look equal length. Don't let your brain assume they're equal length. Force your brain to see it differently. A, B, C, D. These are parallel and parallel. And I'm interested in the diagonals, so draw them in. Okay. Now, right angles. Something one of you said earlier is going to apply here. How do I, what kind of vector thing am I doing to work out if something's at right angles?
Dot product.
And what about somebody else? What about the dot product?
Equals 0.
Good. Okay. If the dot product is 0, they're at right angles. So let me get then the dot product of the diagonals. AC dot BD. Now some people do this proof, and I sometimes do it. You get the label to one side and the label to the other side, and you can do it that way. Or you can just work it out bit by bit. How would you like to do it?
Wait, say that again.
I can do it with lots of big letters, like I did this one. Or I can replace this with P and this with Q,
Just
and
do
we just
big
use little
letters.
P and Q.
Keep the big letters.
Keep the big letters.
No.
It has to be different.
Brian, you have a vote?
Big letters.
Big letters. Okay, big letters today. I'm happy to do it either way. Okay. So, AC.BD, well, I need to go in terms of the parallelogram. So I'm going to replace that with AB plus BC dot, and then BD I'm going to go BC plus CD. I have a dot product, expand the brackets. AB dot BC first, outside, plus AB dot CD plus BC dot BC. I'm running out of room, I'm going to go down a bit instead. BC dot BC plus BC dot CD. Now let's see what we're going to do next. This is a parallelogram. I haven't used this yet, but I'm about to. CD is the same as BA. AB dot BC plus AB dot BA. Okay, CD is the same as BA. Same here. BC dot BC plus BC dot CD is BA. BA.
Can I guess the next move?
Sure, what's next?
Is BA the same as negative AB?
Correct. Correct. AB dot BC plus, minus AB dot AB. And we'll do the same on this one. Plus BC dot BC minus BC dot AB.
Wouldn't it remain positive in the first minus because it was
No,
two angles?
because remember your dot product. Your dot product is this times this, times the angle between them.
Right.
If I turn this vector around, I now have an obtuse angle, so my cosine is negative instead of
Right.
positive. So if you swap the direction of one of them, you have to change the negative sign. From here, I've got to find it from here to here. And from here to here. You swap this around, turn one of the vectors around, you negate
No,
the dot
I
product.
get that, but like, if there was two, wait, am I reading the question wrong? Maybe I am, but
We're nearly there.
no, it's fine, never mind. I just assumed we had flipped both, and it made one negative.
No, only one.
Yeah, sorry, never mind.
But what doesn't matter is what order I list these in the dot product.
Yeah, I get that
Okay.
part.
I'll use a different letter. P dot Q is the same as Q dot P. There's nothing in the definition that tells me which order you do that in. That means this and this are the same.
Can I guess the next step?
That goes away. Okay, what's next?
AB and AB is 1.
No, it's not 1. What's the definition? P dot Q is mod P mod Q cos the angle between them, right?
Yeah.
If these are the same vector, there's no angle between them, cos 0 is 1. So P dot P is mod P times mod P, or mod P squared. So this is just, I'm going to put the positive one first, doesn't matter. BC squared minus AB squared. Wait a minute. This is the length of this side, and this is the length of this side. So this is 0 if they're the same length. And if it's 0, they were at right angles. And this is not 0 if they're different lengths. So if they were different lengths, they're not at right angles. And I have just proven the if and only if in one go.
Can you say that again?
Yes. I'll write it first. Equals 0 if and only if BC equals AB. The only time this is 0 is if these two lengths are the same.
Oh, yeah.
But if these two lengths are the same, then it's a rhombus. And if these two lengths are not the same, then it's not a rhombus. So I've just proven exactly this. Therefore, AC, maybe I've got the words, diagonals AC, BD are perpendicular if and only if ABCD is a rhombus. Do you think you could reproduce that on an exam?
Yes.
Can I just get away with memorizing these full proofs?
Sorry?
Can I get away with just memorizing?
Absolutely.
These full proofs? Okay.
You do have to understand what it's doing because you can be asked other things. But absolutely, if that question turns up on the exam, done. Next one. Prove the midpoints of the sides of a quadrilateral joined to form a parallelogram. Prove midpoints of the sides of a quadrilateral pay attention to what kind of shape we're talking about. One of the mistakes your Year 12 textbook makes is it assumes it's a parallelogram. It's not, it's a quadrilateral, general quadrilateral. So midpoints of the sides of quadrilateral, join to form a parallelogram. Always start by drawing a quadrilateral that is not a parallelogram, a kite, or anything. Draw me 5 very different sides. Sorry, 5. 4 very different sides. Not a trapezium, no parallel sides, no equal side lengths. A, B, C, D. Midpoints of the sides. E, F, G, H. What do you think? Does this look like a parallelogram?
Yeah.
Could be, couldn't it? Can we prove it?
How does that work?
It does not matter what shape quadrilateral you come up with, it still works even if it is concave. It still works.
That's so weird.
We're going to prove it. Okay, for it to be a parallelogram, what do I have to prove?
That there's 2 lines in the same direction.
Which 2 lines?
F to G, E to H.
Good. Do I need to prove the others?
No,
Why not?
because parallelogram only needs.
Not sure everyone else has worked that out. Think about this. If I've got 2, well, just 2 parallel lines enough, but if I can prove that this is exactly the same as that, length and direction, it doesn't matter where I move them, the connections from here and here are going to make a parallelogram. So in a vector proof, I only have to prove that those 2 are the same vector. I don't then have to prove the other sides, as long as I prove these 2 are the same. So yes, these are the same, or you can prove these are the same, whichever you prefer. Because I like nice, neat symmetry, I'm actually going to go EF and HG. Actually, that's also bad, isn't it? FG, EH. Maybe we'll go FG, EH, like you suggested. So I need to prove FG, the vector, is EH, the vector. Well, let's use a similar thing to what we did over here. FG is FCCG. Well, FC is half of BC. And CG is half of CD. Which, like we had before, is half of... Do you want me to write the extra line, or are you happy if I go straight to BD? Do you want me to do the factorise like I did over here, or are you okay with that?
That's fine.
That's fine.
Where'd you get BD?
It's just
BC plus CD. BC plus CD is the same as going straight from B to D.
Yep.
So this is half of that. In fact, it's the same as this. This is half of that. But then, wait a minute, I can do the same thing with EH, right? EH is E to A to H. You can probably finish it from here. EA is half of BA plus half of AD. Oh, that's half BD, which means it's the same as FG. So, this is the same vector as this, and that means this has to be a parallelogram. Therefore, EFGH is a, I'll write the whole word, parallelogram. Two down, two to go. Okay with that one? Do I need to move this? What's the next one say? Prove the sum of the squares of the lengths. This is the longer one. The sum of the squares of the lengths. Oh, I better write it. Prove the sum of the squares of the sum of the squares of the lengths of a parallelogram diagonal. Squares of the lengths of a parallelogram's diagonals is equal to the sum of the squares of the lengths of the sides.
No.
Sum of the squares of the lengths of the sides. It is a parallelogram, so draw a parallelogram. But don't make it a rhombus, don't make it a rectangle, parallelogram. A, B, C, D, parallel, parallel, parallel. The sum of the squares of the lengths of the diagonals, I better draw the diagonals in. I have to prove the sum of the squares of the lengths of the diagonals. So the length of
BD plus AC.
Square. Well, sum of the squares of the lengths, not the square of the sum, plus BD squared equals AB plus BC plus CD plus DA for the sake of argument. Doesn't matter which way I go. Squared. The sum of the squares of the lengths of the diagonals equals the sum of the squares of the lengths of the sides. Make sure I know how to start this one properly. Because this one is a mess. They use little letters. Oh, yes. So, it's a parallelogram, right? So let's start with the right-hand side and go. AB squared plus BC squared. CD is the same as BA, and I'm squaring the length so I can actually go AB. And DA is the same as AD is its length, but that's the same as BC. Got my arrows. Do you agree with that?
AB anyway, because you're getting the length.
Yeah, because I'm only getting the length, I don't care. Correct. I don't care about direction because I'm only interested in the length.
You says because it's squared.
Well, yeah, length squared. Don't care. Squared's going to throw away negatives anyway, even if I've got a negative out of it. Which is to say 2ab squared plus 2bc squared.
Do you turn the left hand side into ABBC?
Uh-huh. Okay. AC is AB plus BC. AB plus BC squared. And BD is BC plus CD. I wonder if I'm better off.
You can put an AB, can't you?
Yeah, I'm going to replace that immediately, and I'll tell you why.
It's easy to expand.
Well, what I actually want to do is I'm going to do it in slightly different order. Hold on, I'm doing it in slightly different order because this one is definitely easier with smaller letters. Can I replace them with smaller letters because it's a little bit less to write?
Yes.
Yeah, you like this. They all said no. I'm going to replace let A, B. I need two letters. P and Q,
W.
X and Y.
W and L.
Not an L, I don't like L.
Okay.
PQ.
PQ, you okay with P and Q? They're mirrors of each other. E and F, whatever. Okay.
W and E.
Just anything with W.
You can use whatever you like in your version.
Okay.
P.
You asked what letters you wanted.
I know, but I have opinions as well. Okay, so my left hand side is AC. Oh, so AC squared, remember I had it up here before, is AC dot AC. Remember I said that before? Something dot itself is the same as its length squared. And now it's going backwards. AC squared plus BD dot BD. Now I'm going to go. AC, what did I call? This one was, let me get another colour. AB is P and BC is Q. So AC is P plus Q. Dot P plus Q. Get the Q's and the P's the right way around. Plus, what's BD?
AD.
BD
Oh.
is Q minus P. Q minus P. Q minus P dot Q minus P. Do you want to have a go? Expand those brackets out carefully like we did over here. Expand the brackets out, every possible pairing, see what you can cancel out. Have a go.
Can we write squared or no?
No longer squared. I'm replacing the squared with a dot product.
No, I mean like we can have.
No, just write P dot P and Q dot Q.
Okay.
Well, you are eventually, yes, you're going to get like this. It's going to end up like this.
Yeah.
Remember, this is actually now 2P squared plus 2Q squared. That's what we're aiming for.
Yep.
Should use a different colour for that, hang on. That's my goal. I'm aiming for this. P dot P plus P dot Q plus Q dot P plus Q dot Q.
What's in the far right bracket?
Q minus P.
Q.
It's this one squared.
Yeah, the Q looks funny.
It does. If you like, you can put the squiggle further down. Is that clearer?
Mm-hmm.
Doesn't matter. Q dot Q minus, carefully, Q dot P minus P dot Q plus P dot P. Keep going. So I have 2P dot P. I have P dot Q. These are the same thing, but P dot Q minus P dot Q, Q dot P minus Q dot P. I'm left with 2Q dot Q. Oh, look at that. Equals left hand side. No, right hand side was right. That's the messy one of the four. You can do this everywhere you've got P, you're going to write A, B, and everywhere you've got Q, you're going to write B, C. It just takes more space. It's big enough already. You've already done this without vectors. Year 11's, notice we are using a vector method to prove the angle in the semicircle is a right angle. And then next week we'll come back and show the same thing without vectors. Two different ways to prove it. Do you remember the other way?
I remember you showed us a video before we started.
Okay.
The guy like drew on wood or something.
Oh, yes. Okay, I remember that, yes.
Can we watch it?
No, you don't need to watch that right now. Okay. Prove an angle in a semicircle is a right angle. What does that even mean? Prove an angle in a semicircle is a right angle. What are we even talking about? Talking about this. We want to prove that this angle is a right angle.
Like always.
Always. As long as you start with a semicircle.
When you draw two lines to any point.
What do you mean? Yeah, correct. Any point on the circumference, correct. You will always get a right angle.
But isn't it just any point? We did an assignment on this in grade 7 actually.
Oh, did you?
Yeah. It was like mini golf and like any point that you hit
Yes.
would come off at 90 degrees.
Uh-huh.
Yeah.
If it's a semicircle, correct.
Yeah. I remember this.
So, can we prove this? Let's put the origin at the centre here because we can. A, B, C. I'm going to draw in 3 vectors. From the origin. And a little a goes to capital A, little b goes to capital B, little c goes to capital C. Now, if I have to prove that this is a right angle, that means I have to prove that AB dot BC is 0. Same as we did before, to prove a right angle, dot product is 0. So let's have a look at AB dot BC. Let's see where we get. Well, AB is just B minus A. And BC is just C minus B. Expand brackets.
O is the midpoint, right?
O is the midpoint, correct.
So C
Because it's the centre, they're all the same.
does that mean C is negative A?
Correct. You can replace it here if you'd rather. I'm going to expand it out and show what happens. B dot C minus B dot B minus A dot C plus A dot B. It's a little hard for some people to see if I just replace here, but if I replace here, it should be clearer. All right, what happens here? Well, B dot C. This one's easy. That's just the length of B squared, right? Let me replace C with negative A. See how they're opposite direction but same length because they're both radii? So that means this is negative B dot A. This one is length of B squared. This one is, C is negative A plus A dot A.
Why did you simplify the B and not the A?
A dot B. Sorry?
You simplified B squared but not A dot A.
I'm trying to do one step at a time. I'm replacing the C with an A. Oh, now I can see this is A squared.
Wait, sorry, I missed the very first part, the B dot A.
C is negative A. Yes?
Yeah.
So wherever I see C, I'm replacing it with negative A. Okay, just for you.
No, I got it. Yeah,
I'll
that
do
makes
one
sense.
thing at a time.
No, that makes sense, it's fine.
I'll replace it on the next line. Yeah, I'm just replacing C with negative A.
Okay, that's all, yeah.
Same here, C with negative A. What have I got? Negative. Oh, these are the same, aren't they? Right, A dot B and B dot A are the same. So that one goes away. And I've got negative length of B squared plus length of A squared. Wait a minute. They're both radii. They've got the same length.
Wow.
Therefore, angle ABC is a right angle. No matter which point B I choose around the circumference, it's always a right angle.